Hi, this is Mrs. Kidman, and in this video, we're going to be talking about how you can solve polynomials using square roots when we have both real and imaginary solutions. Now, when it comes to solving polynomials, there are lots of different ways to do it. We've talked about how you can do it by factoring. Other ways that you are able to solve polynomials is you can also use square roots, which you will see in this video. You can use the quadratic formula, which you've learned before, and we will review. As well as you can use graphing or something called the rational root theorem. So graphing and the rational root theorem. All of those are awesome different ways to do this. In this video, we're specifically going to be touching on solving by square roots. Now, as a quick review, when it comes to solving, you can have both real answers and you can have imaginary solutions. So when it comes to imaginary solutions, those are the ones that have I in them. Now, before you get terrified about imaginary solutions and what I is and where it comes from and why it's important, don't worry about it, right? I is defined as being the square root of -1. The reason why we use I in math is because at some point someone was like, why would we stop ourselves from solving all of these equations because we have to take the square root of a negative? That seems silly. So what we did is someone said, well, what if we just define the square root of a -1 as being I? So what you have to do is whenever you're solving something, so say you wanted to take the square root of -4, right? We're taking the square root of -4 here. What we want to do is we want to see it as being the square root of -1 times the square root of 4. Well, the square root of 4 is 2 and 2, or it's -2 and -2. So the square root of 4 just equals 2 or -2. But because the square root of 1 equals I, all that happens here is we just tag an I onto those. So as you're going to find that square root, the square root of -4 is just 2I or -2I. The square root of -16 is just 4I or -4I because the square root of 16 is just 4. So knowing that, if you have something like the square root of -6, the answer to that is just the square root of 6I and the negative square root of 6I, right? A lot of the time people don't end up putting that I at the end with these ones though. You'll often end up seeing I square root of 6 and -I squared root of 6. The reason why is typically we write I afterwards when it means a variable, but with those radicals, it can get a little confusing. So just put that I out front. So anytime there is a negative inside, you just pop the I outside and you write it the same. So take a moment to think, what would the square root of -10 be, right? Well, the square root of 10 doesn't come out pretty. So we're going to end up getting I square root of 10 and -I square root of 10. And these answers here are totally valid and totally okay. So if there's a negative inside, this is what we want to know. If you have a negative inside of your radical, and it's a square root, then it's just going to be I positive or -I times the square root of the positive version of that number, okay? Anytime. So the square root of -4 is 2I and -2I. The square root of -7 is going to be I root 7 and -I root 7. Okay, you could even write these ones as I2 and -I2. It looks weird, but it's right? So however you want to write that is totally fine. So now we're going to talk about how we actually solve using square roots. Now, anytime you solve using square roots, the key here is your polynomial must equal 0. The kind of to start, then you can move on from there. So most of the time we equal 0. That's how we do it when we were factoring. That's how you do it when you are solving by the quadratic formula. The only exception here is when you solve by square roots. When you solve by square roots, you want to get your x squared all alone on one side and equal to your number. So anytime you do this, your first step is to get your x squared alone. Okay, so let's take a look at question number 1 here. If we want to get x squared alone, we are going to divide by -3 on both sides. So I end up getting x squared equals 25. Now, if I have x squared equals 25, what I want to do next is I want to get rid of the square. So our second step is to get rid of the square. The opposite of squaring something is square rooting it. So our second step is we want to square root both sides. Okay, so we literally are just going to come in here and draw square root on both sides. What this does is because of this 2 right here, that 2 tells us they're going to be 2 different solutions. So what you need to do is you need to figure out what both of those are. So what number times itself is 25? That's what a square root means. So x is 5, but x is also going to be -5, right? So after you square root both sides, your third step is to make sure that you write the positive and negative version of the answer that you get from your calculator, right? So +5, -5. Now, when you're doing these, I want exact answers. So when it comes to being exact answers, that means no decimals. You got to write whole numbers here, right? You can write a fraction if you want to, but you got to write these whole numbers. You got to write these numbers that way. So let's take a look at question number 2. We want to get our x squared alone. So I'm going to start by minusing 12 from both sides. So I get x squared equals -2. Now my second step is to square root both sides. Square root, square root. So x equals, oh shoot, I've got the square root of a negative, but I know how to do that, right? That just means we have this imaginary. So x is going to equal I times the square root of 2, because 2 doesn't square root nicely, and x is going to equal -I times the square root of 2. So if it doesn't square root nicely, you just write the radical. If it doesn't square root nicely and it's negative inside, you put I on the outside and then square root it. Okay, so let's take a look at this next problem here. As we're going through this, we are going to erase our steps here. So hopefully you have them all written and you can refer to them in your notes. So as we go through this, our first step is to get x alone. So we're going to do that by adding 15 to both sides here. So I end up getting 4x squared equals 0. Then I divide by 4 on both sides, and x squared equals 0. You guys, this is okay. So as I go to get rid of that square root, I'm going to square root both sides. Go ahead and pull out a calculator. What is the square root of 0? That's right, it's 0. So x is going to equal 0. Now, you could say that x also equals -0, but that doesn't really make any sense. But I guess -0 is fine. So you could write both of those, but really x equals 0 here. And it just equals 0 in lots of different weird ways, whatever ways you want. So let's take a look at a couple more examples on how we would do this. So remember, step 1, we want to get our x squared alone. Okay, our step 2 is we want to square root both sides. And step 3, we want to make sure we have the positive and negative version of our answer. And remember, if you take the square root of a negative number, it's just going to be positive and -I times the square root of whatever that number was. Okay, so let's take a look at this one here. We are going to subtract 8 from both sides. I get x squared equals 11. So my next step would be to square root both sides. And we get x squared equals the square root of x equals the square root of 11. But I also want the negative version, so x equals the negative square root of 11. Now, when you type that into your calculator, you're going to notice that it's 3 and some change, right? 3 point whatever. We don't want the point whatever. If it doesn't come out as a whole nice, pretty number, then just write square root of 11, right? There's no reason for us to use decimals here if we don't need to. Okay, let's take a look at at this next one here. So we are going to get that x alone by adding 2 to both sides. I end up with 5x squared equals, sorry, that 5's a little sloppy there. 5x squared equals 2. We can divide by 5 on both sides. And we get that x squared equals 2/5. Okay, now you can write that as a 0.4 if you want to, but 2/5 is totally fine. Now, after we get that, we want to square root both sides. So I square root this side, square root this side. X equals, well, the square root of 2/5 doesn't come out nicely. X literally equals the square root of 2/5, and x equals the negative square root of 2/5, right? Totally valid, totally fine, right? Just say that it equals the positive and negative version of that. Now let's take a look at one more question here. We are going to add 30 to both sides. We get 3x squared equals 34. I divide by 3 on both sides. X squared equals 34/3. Ew, gross. But does it actually matter? Not really. Because all I need to do is square root both sides. If this doesn't square root nicely, oh well. I'm just going to write x equals the square root of 34/3. And x equals the negative square root of 34/3. And look at that. We can find it there. So looking at one more example that might give us a negative, if we have something like 2x squared minus 4 equals -8, something like this, what we can do is we can add 4 to both sides. I get 2x squared equals -4. Divide by 2, divide by 2. X squared equals -2. I want to get rid of my squared. I square root it. Awesome. Okay, now when we go to square root it, we got to write our answers. Well, it's a negative inside. So when it's a negative inside, I'm going to write x equals I times the square root of the number. What's the square root of 2? It's just the square root of 2. But I also want the negative version of that. So x equals -I times the square root of 2. And that is how we're going to solve those. So if you have any questions, don't hesitate to ask. But that is how you can solve using square roots when it has positive and negative inside of our radicals there. So imaginaries and reals.